If you're looking to run Dante in your network with MikroTik switches, then you have come to the right place. I will explain everything you need to know. First up, you want to make sure you have the right tools for the job. A common concern is that the energy-efficient Ethernet does not play well with Dante, so you want to avoid it. Luckily for you, none of our switches ship with that feature, so you can't even accidentally enable it. Another concern you might have is the throughput that you need. For an audio-only setup, 1 gigabit switches are more than enough. Ideally, you want to go for something from the CRS range, as the CSS devices use a more simplified software that does not have all the features that you might want, but they can work alright if that's all you got. To give you a couple good options to choose from, consider something like the CRS 32624G, or you could go for the CRS 320 if you need to power some things with PoE. Now, if you're looking to do Dante with video as well, most likely you want to get some 10 gigabit gear. We got some exceptional 10G options coming out by the end of this year, but for now I want to highlight this little guy, the CRS 304 4XG. It is completely passively cooled, so it is dead silent. You can put it right next to the microphone in a recording studio and you won't pick up a thing. The only downside is the port count, so obviously it is not going to be the backbone of some huge setup. Next up, when you have your chosen switch, you will want to tweak the configuration for Dante. And once you have done that, there is nothing else to worry about. Dante needs to be prioritized above other traffic in your network, and there are optimizations within the Dante traffic itself. This is achieved through what is known as differentiated services in networking. It is one of the methods used to ensure quality of service. When Dante sends audio, video, or any other type of data over your network, it puts them in IP packets, and it marks each packet with a special DSCP value according to the type of data is being sent and how it should be prioritized. So let's set up our switch in a way where it reads those DSCP values and prioritizes Dante traffic. First, you want to make sure that QoS hardware offloading is enabled for your switch. And then you want to go to Switch QoS. In the Port tab, you will want to change the Trust L3 setting on the specific ports that we will want to use for Dante. This tells the switch that it needs to respect the DSCP values in the incoming IP packets. If you have to change all the ports, the quick option is to open a terminal and type in interface Ethernet switch QoS port set find Trust L3 keep. This changes the setting on all ports. Next, click the Profile tab. Here we have to add a profile for Dante PTP with DSCP value of 56, and then you want to set the traffic class to 7. Optionally, you can also set the PCP value to 7, but doesn't really do anything if you are not running Dante through VLANs. Then we want to add another profile that we are going to call Dante Audio, and is going to have a DSCP value of 46 and traffic class 5. Optionally, set the PCP value to 5 as well. Now we got two profiles that the switch will use to recognize different types of traffic and send them to priority queues. In the IP DSCP tab, you can see that two new entries have been created dynamically. This is how the switch recognizes the traffic. And then it takes the traffic class numbers from the respective profile settings to put the traffic in different queues. We can control the queue priorities in the TXQ tab. We use traffic class 7 and traffic class 5, and we want to make sure that both of them are set to schedule strict. This makes sure that the higher traffic classes get processed strictly before everything else. And in this case, 7 always goes before Q5. We don't have to worry about all the other settings here. The highest priority queue is for PTP or Precision Time Protocol. It sends a very small amount of data, but you want it processed rapidly with very little latency so that all your Dante devices can synchronize properly to the nanosecond. The actual audio goes into Q5, where it again will experience very little latency and it will have access to all the bandwidth it needs. Since we did not create any other profiles, all other traffic in your network will go into traffic class 0, where it just gets processed to the best effort after the high priority stuff. For best results with Dante, we recommend not creating any additional profiles, as you are likely to shoot yourself in the foot and reduce the processing efficiency for these two high priority types of traffic. Besides quality of service settings, you might also need to adjust some multicast settings. Multicasting lets you take one source of audio or video and send it to multiple locations in a way that can preserve networking resources. Your Dante ports need to be in a single bridge, and with default configuration, that should already be the case. In the bridge settings, click on the IGMP tab and simply enable IGMP snooping. For IGMP setups to work correctly, one of the devices has to act as an IGMP querier. If you think you need one, you can have the switch play this role as well. Simply enable the multicast querier option and change the query interval to 60 seconds. Then in the Bridge Ports tab, you will want to enable the Fast Leave option. And again, you can use the terminal with the set find command to apply this to all the ports at once. This concludes the switch configuration you need for the best Dante performance in your network. Additionally, our switches can act as precision time protocol boundary clocks, but it is not necessary to set that up. Simply prioritizing PTP packets is enough. But if PTP is of a particular interest of yours, we will explore it at depth in another video. Meanwhile, let me know in the comments if there is anything of concern for you when it comes to the use of our switches in the audio-visual domain.